Hello, welcome to this lecture of Biomathematics. In the last lecture, we have been discussing about vectors. We introduced the idea of vectors and we discussed why would we need to use vectors at all. And we found that, for example, if you want to calculate the force between charges on a protein or any system, any charge system, you would need vectors. To also represent like the motion, flow, all those things are very important thing in biology. For all this to mathematically represent, to convey this idea mathematically, one need to use the idea of vectors. So, in this context, we also ask this question: if you have three charges, what will be the force on one of the charges due to other charges? And as an exercise, we wanted to calculate this clearly, explicitly, so that as an example you all will know how to calculate force on a charge due to other charges. And through this we will learn many ideas of vectors. By calculating this force, we will learn many things about vectors. So, let us go and see what the question we were asking, just to remind ourselves what exactly the question we were asking. So, this lecture is vectors part 2, and the question we were asking is basically three charges and calculating the total force. And the aim of the thing what we want to understand is that if you have this negative charge and two plus charges, in which direction the negative charge will move? Will it move this way? 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 So, in which direction will it move? That is a question, and that is what exactly we are trying to answer. So, while answering this, we did to begin with, to do this, we did a few things. We calculated the position of each of these charges. So, if we say that this is in an xy plane and this is sitting at the plus 4 on the x axis, this q1 is sitting on the minus 6 position on the x axis, if q2 is sitting on plus 8 position of the y axis, we said that r1, which is the position of the first charge, is minus 6x, r2 is plus 8y, and r3 is plus 4x. So, we said this, and we also calculated the distance between first charge and second charge, the distance between the first charge and the third charge, and the distance between the second charge and the third charge. So, this distance is basically shown here. So, what is shown here is basically r12. So, this is where we stopped in the last lecture. We calculated r12. R12 is the distance between this charge and this charge, that is the first charge and the second charge. R23 is the distance between second charge and the third charge, and r13 is the displacement vector of this charge 10 between first charge and third charge. So, all these are vectors and there is a direction for all this. Now, there is a meaning for all this, like think about what exactly this 8y plus 6x means. So, or in other words, this is 6x plus 8y, right? This, you can either call it 8y plus 6x or 6x plus 8y, they are the same. Now, what does this mean? If you think about it, there is a 6x, that means, so this says that to go from first charge to second charge, you have to go 6 along the x direction and 8 along the y direction. So, that is what it means, 6 along the x direction and 8 along the y direction. If you go from 6 along the, if you travel or if you move 6 along the x direction, that is from here to here, and 8 along the y direction, that is from here to here, you will reach the second charge. That is what precisely this means. Which way you have to move such that you will get from the first charge to the second charge, and how much you have to move, that is what it is. And R23 is from the second charge to third charge, which way you have to move, this is the way you have to move, and how much you have to move, that is what is coded into this vector R23. So, when somebody says R23 is 4x minus 8y, so first you have to do minus 8y, that is you have to come down minus 8, the decreasing direction of y, you have to come 8. So, 8 along the minus y, that is what minus 8y means. 8 along the minus y you have to go, then 4 along the plus x. So, minus 8y plus 4x. So, that is what this is, minus 8y plus 4x. That is what this means. That is, to go from 2 to 3, you have to travel 8 unit along the negative direction of the y axis and 4 unit along the plus direction of the 4x axis. What does R13 equal to 10x means? To go from 1 to 3, you have to just travel 10 unit along the x axis in the positive x direction. That is what it is. You do not have to go along the y axis. So, there is no y component here. So, from this, when you say a displacement vector r12, r23, etc., it has some meaning. Take this slide, hold it and think about it. Just spend some time with this slide and convince yourself that r12 is nothing but the distance to go from 1, the way to go from 1 to 2, what kind of, where you have to, which direction you have to travel and how much you have to travel. That is what precisely encoded in this R12. When you say that R12 is 6x plus 8y, that means to go from 1 to 2, you have to go 6 units along the x axis and 8 units along the y axis. So, it is a recipe to move if you want, if you wish. This is some kind of a recipe given to you to know which direction, how exactly you have to move, precise information. So, if somebody says 6x plus 8y, this is a precise information how much you have to move, in which direction and all that. So, there is some meaning. If you wish, take a graph paper and mark all this in the graph paper and then do it yourself and convince yourself, and the only way to learn, I think, is to do this yourself and convince yourself. Okay. So, we understand the distance or the distance between this. Now, we have to calculate the force. So, again let us go back to the question. So, here if you look at the slide here, the question we want to ask is the force on the second charge. What is it? The force on the second charge F2 is F21 plus F23. What is F21? F21 is force on the second charge due to the first charge. That is F21. Force on the second charge due to the first charge. So, the first charge will try to attract this and with some force. So, that is this F21. F23 is force on the second charge due to the third charge. The third charge will exert some force on the second charge. As you know, these are plus and minus charges. So, this plus charge will try to pull this, attract this. So, there will be some force along this direction due to the third charge, that is this one, and there will be some force along this direction due to this charge, that is F21. Now, if there are two forces, in which way will it move? Precisely you have to know where exactly, precisely in which direction it will move. So, this is what we will calculate. So, now of course, we will start calculating with F21, we will precisely calculate this number F21. If we have this F21, then we can calculate F23 and sum this and you get the answer F2. So, let us go ahead and see how do we calculate F21. So, here have a look at this slide. In this slide you have two charges, again Q1, Q2 as we had, and we knew that this R12 is 6x plus 8y, and the magnitude of the force F21, we know that Q1 Q2 by k r square is the magnitude of the force. This is the Coulomb's law. The Q1 Q2 k is a constant which is 4 pi epsilon 0 epsilon r, and R12 square, this is the distance square between these two charges. Now, how do we calculate this distance between these two charges R1? So, you can see here two lines. So, this lines represents, this lines is called magnitude. So, this two lines, if you put a vector between these two lines, that means magnitude of a vector. So, have a look at here. When you say A is a vector, and if you say this means what is the magnitude, how or if you want like R is a vector, and if you say mod R, this is the magnitude of R, or you can also, if this is a vector, it's a distance vector what like we had. So, let us say we had a distance vector here r12 and we had this magnitude of r12. So, while we, since we are going to learn how to calculate the force, when we do this, we will go ahead and learn a few things through this. So, while we learning the calculation of the force, we will learn some concepts in vectors also, and this one of these concepts is magnitude of the vector. So, this is a displacement vector, and the magnitude of the vector actually means, so this also would mean the magnitude. So, this is another concept in the vector algebra. So, magnitude of a vector, how do we calculate this? So, while we calculate the force, we will learn how to calculate this and which will be used to calculate the force. So, that is the strategy we are going to use. So, let us learn how to calculate this r12. So, r12 as I said is magnitude, it is also the distance of the vector. That is, if you have a vector like this from here to here, this distance, if this is r12 vector, at this distance is called mod r12. Mod r12 will give you the distance from here to here. So, this is what will be represented in mod r12. Now, how do we calculate this mode? That is what we will discuss. So, if you have any vector, let us say A, and if the vector is 3x plus 4y, mod A is mod 3x plus 4y. So, this is calculated as root of, take the coefficient of x, square it, plus take the coefficient of y, square it. So, this is the mod A. So, this is 3 is square is 9, this is 16. So, this is root 25. So, this is 5. 5 is the magnitude of this vector A. That is what it means. If we have any vector v, which is v1 along the x axis and v2 along the y axis, mod v is equal to square root of v1 square plus v2 square. That is the formula for magnitude of a vector. So, this is magnitude of a vector. So, in the case where we are discussing, what we want to calculate is actually the magnitude of force. So, we had force is equal to q1 q2 by k r12, this is r12, this is r12 magnitude square. So, have a look at this slide again. So, we had r12 square here. So, when you have this r12 square, the mod r12 as we just discussed. So, r12 is nothing but 6x plus 8y, 6x plus 8y is r12. The way to calculate r12 is basically mod r12 can be calculated as we say, as we just discussed, is square root of the coefficient of x, which is 6 square, plus coefficient of y, which is 8 square. So, mod r12 is equal to root of 6 square plus 8 square, which is root of 6 square is 36, 8 square is 64. So, 36 plus 64 is 100. So, square root of 100 is 10. So, mod r12 is 10. So, mod f21 is q1 q2 by k into mod r12 square is 10 square, which is 100. So, essentially q1 q2 by 100 k is the magnitude of this vector. That is the force, the magnitude, how much force this q2 will feel is q1 q2 by 100 k. If you know the q1, if you know the q2, this is the force. So, let us just discuss what we discussed about magnitude once more. If you have any vector A in 3D, let A be a1x plus a2y plus a3z, that is a1 is the component along the x axis, a2 is the component along the y axis, a3 is the component along the z axis. Magnitude of the vector or the length of the vector is mod A, which is equal to root of a1 square plus a2 square plus a3 square, coefficient of x square plus coefficient of y square plus coefficient of z square. So, this is the way to calculate the magnitude. So, now let us go back to the force. We know the magnitude of the force now, which is q1 q2 by 100 k. Now, the question we want to ask is, what is the direction of the force? We know the magnitude of the force, we know how much force the q2 will be felt, but which direction will the q2 be pulled? So, as you know, q2 is negative, q1 is positive, the q2 will be pulled towards q1. There will be an attraction, q1 will attract q2. So, if you fix q1 here, q2 will be pulled towards q1. So, q2, the force will be in the direction opposite to the direction of r12. Have a look at here r12. R12 is from 1 to 2. R12 is from in this direction to the point, arrow is pointed in this direction. Arrow is pointed from 1 to 2. The R12 is pointing from 1 to 2. But we know that the force will be pointing from 2 to 1, because the second charge will be pulled from from here to here. So, the direction of this force will be opposite to the direction of the R12. So, q2 will be attracted towards q1, which is nothing but opposite to the direction of R12. So, we know the magnitude, now we know the direction, but how do we know the direction now in sentence? We know it will be opposite to the direction of R12. But how do we say that in mathematically? This is how we do it. So, have a look at the way we do is the following. So, we say that the direction f21 cap or hat. So, when you say hat, as we said, it's like a unit vector, and unit vector represents direction. So, the direction of f21 is minus r12. This is opposite to the direction of r12. We just saw that r12 is from here to here and f21 will be from here to here. It will be opposite, minus shows the opposite sign, represents the direction, minus is in this sign. So, in the opposite direction of r12. So, the point here to remember is hat or cap means that it is representing the direction. If you have some magnitude and a cap, it represents the direction. So, if we had x cap means the direction along the x axis, y cap meant direction along the y axis. So, z cap would mean direction along the z axis. So, r12 cap would mean direction along the r12, but with a minus sign, r12 cap with a minus sign would mean opposite to the direction of r12. But now, how do we calculate this r12 cap? What exactly this r12 cap is? We know what is x cap, we know y cap. How do we calculate this r12 cap? So, the way to calculate r12 cap is again definition of a unit vector. So, we will learn now how do we define a unit vector. So, the definition of a unit vector. So, let us say you have a vector A, which is from here to here. Now, we want to know that something is going in the direction of A, if we want to know this direction, so that can be represented by unit vector A, which means it only shows the direction. Unit vector only shows the direction. This magnitude is 1. So, we know that mod A cap, that is modulus of any magnitude of any unit vector, is 1. So, now how do we define? This is defined as A vector by mod A vector. This is the definition of unit vector. Any unit vector is that vector divided by its modulus. So, let us think about this a bit carefully. So, let us say you have vector A, which is nothing but A 1 along the x axis plus A 2 along the y axis. So, let us say in our case A 1. So, this is, let us say, as we said, 3 x plus 4 y. Now, mod, what is A cap? We said A cap is A vector divided by modulus of A vector. Now, we said that modulus of A vector is nothing but root of 3 square plus 4 square, which is this coefficient of this square plus coefficient of this square. So, this is 9 plus 16 is root of 25, this is 5. So, A cap is 3 x plus 4 y divided by 5. What is this? 3 by 5 x plus 4 by 5 y. So, this is how we calculate A. So, this is 3 by 5 x plus 4 by 5 y. So, the unit vector along A is nothing but some, you have to go, if you say, if I am pointing in this particular, if I show you in that direction, that means a little bit north, or there will be like, if you come little bit right and then straight, or north south. So, this is like when you say something x plus something y, you have to go something along the x axis and something along the y axis. So, similarly, if I say here, if you look at this 3 by 5, which is a number, this much you have to go along the x axis, and 4 by 5, which is another number, you have to go this much 4 by 5 unit along the y axis. If you go this, you will get the direction of the vector A. Now, as we said, mod of A cap has to be 1, that is the definition of A cap. Now, will this mod of this will be 1? We can have a check, we can check. So, we had A cap as 3 by 5 x plus 4 by 5 y. Mod A is mod of this, which is square root of 3 by 5 square plus 4 by 5 square. That is the mode of finding any vector, mode of anything. So, 3 by 5 square plus 4 by 5 square. What is it? So, 3 by 5 square is 9 by 25 plus 16 by 25. What is it? This is root of 25 by 25, which is 1. So, we defined mod A cap in a particular way, and we defined in that particular way because at the end of the day we want to get mod A equal to 1. And here, as you can see here, if you define, if you define A as 3 by 5 x plus 4 by 5 y, mod A is essentially, if you 3 by 5 square plus 4 by 5 square root, which is essentially 1. So, we get that mod A is 1. we calculate the direction, the unit vector representing the direction. So, now we go ahead and calculate r12 cap. So, have a look at here. So, the r12 cap, so we know that r12 is 6x plus 8y, r12 cap is r12 divided by mod of r12. So, r12 is 6x plus 8y, mod of r12 is root of 6 square plus 8 square. So, that is what it is. So, what is 6 square plus 8 square? 6 square is 36, 8 square is 64. So, 64 plus 36 is 100 and root of 100 is 10. So, what you have in the denominator is 10. So, 6 by 10 is 0.6, 8 by 10 is 0.8. So, essentially mod cap r12 or r12 cap or r12 hat is nothing but 0.6 x plus 0.8 y. Let us have quickly look whether mod r12 is unit vector or not. So, what did we get? We got mod r12 is 0.6 x plus 0.8 y. Mod r12 cap, this is nothing but square root of 0.6 x square plus 0.8 square. So, this is equal to square root of 0.36, 0.6 square is 0.36 plus 0.8 square is 0.64. What is this? 0.36 plus 0.64 is 1. So, this is essentially 1. So, we got mod r12 is 1. So, again r12 is a unit vector which represents the direction. What does it mean to say? So, you can here you have it here 0.6 x plus 0.8 y, that is mod r12. So, putting all this together, what is the force? So, we know the magnitude, we know the direction. Now, we can put together magnitude and direction to get the force. So, the force F21 will be in this particular direction and the magnitude is q1 q2 by k r12 square and the direction will be r12 cap with a minus sign. So, this is the total vector which is q1 q2 by k r12 whole square, k r12 square, r12 cap with a minus sign. And r12 cap we saw that it is 0.6 x plus 0.8 y. So, if I substitute for r12 cap here, what do I get? I get F21 is equal to 0.6 into q1 q2 by k r12 square, which is so we saw that r12 square is 100. So, q1 q2 by 100 k x minus 0.8 into q1 q2 by 100 k into y. So, this is what this tells us, that F21 is this. Now, what does this mean? So, F21 is, what does it mean? F21 has some x component and F21 has some y component. This means that the Q2 will feel some force of this amount. So, you substitute for Q1, substitute for Q2, let us say this is number 1, 1. So, this is 1 and let us say k is some number. So, essentially you will get a number here which is a negative number after all. So, that much minus x direction you have to come. You have to some force will be felt along this direction and some force will be felt along this direction, which is along the minus y direction. So, this much force will be felt along the minus y direction and some force will be felt along the minus x direction. So, minus x direction some force, minus y direction some force. So, that is the total force that will be felt on this charge 2 due to charge 1. Charge 1 some direction, so it will pull a bit down, it will also pull a bit sidewise. It will get pulled a bit downwards, it will get pulled a bit sideways. So, it will come here a bit, go here a bit. Where exactly this will go, that we will calculate later, but how much force is being felt is what we have calculated. The amount of force is this much and the direction of the force is this much. So, we know now how much is the force being felt on the second charge due to the first charge. Similarly, we can go ahead and calculate other forces also, that is force on the second charge due to the third charge can be calculated. So, that is what our aim is. We want to calculate now force on the third charge due to the force on the second charge due to the third charge. So, let us go ahead and calculate this force on the third charge due to the second charge. So, let us have a look at this. So, here we know that R23, so we have charge 2, charge 3 and we know that R23 is 4x minus 8y, that is to go from 2 to 3 you have to come along the x axis 4 and minus y 8 unit along minus y. 4 unit along x, 8 unit along minus y you to reach here. Now, what is the force? We know that the magnitude of the force is q1 q2 by k r23 whole square. This is the magnitude of the force. What is the direction of the force? We know that since if you fix this charge here, this charge will be attracted towards this charge. Q2 will be attracted towards Q3. So, the direction will be this direction and which is the same direction as that of R23. So, R23 is along this direction and F23 also will be along the same direction. So, F23 will be in the direction of R23. So, we said that in a minute ago we discussed that to show the direction of anything we have to use unit vector. So, we use unit vector R23 to show the direction along R23. So, how do we define unit vector R23? So, let us look at this next slide. So, R23 is this and unit vector R23 as we have been defining R23 vector divided by mod R23. What is R23 vector? R23 vector is 4x minus 8y. So, which is and mod R23 is root of 4 square plus 8 square, 4 square and plus 8 square. So, this is the mode of R23 because even if you call it a minus 8 square is like plus 8 square only. So, this is basically 4 square is 16, a square is 64, 64 plus 16 is 80. So, the denominator is square root of 80. So, R23 if you look here. So, we had R23 as 4x minus 8y and mod R23 is root of 4 square plus 8 square, which is root of 16 plus 64, which is square root of 80. And R23 cap, that is the unit vector along R23 is R23 divided by mod R23. So, this is 4x minus 8y divided by square root of 80. So, this will be this R23 cap. So, have a look at here. So, essentially F23 is some magnitude into 4 by root 80 x. This is the unit vector along the x, R23 unit vector if you substitute, and this is just like we did the case of F123, we substitute here and we get q1 q2 by 80 k into 8 by root 80 y. So, this is an x, some component along the x direction and some component along the minus y direction. So, there will be some force along the x direction in this direction, there will be some force downwards along y. So, that is what this means. Essentially, this means that there will be some, all these are numbers, so all this is a big number. So, there will be some number of some amount of force along the plus x direction. So, this get pulled some amount towards rightwards in this direction, towards the plus x direction. Some amount of it will get also a pull towards minus y direction. So, it will get pulled this way and this way. So, how much where it will move, that we will see later, but the amount of force F23 is this much. So, F23 is now calculated. So, we calculated F12, F23. So, if we know that F21 and F23, what we need is the total force, and as we have been saying, the total force F2 is F21 plus F23. So, what is F21? F21 is minus 6 q1 q2 by 100 x plus 0.8 q1 q2 by 100 k y, that is F21. F23 is q1 q2 by 80 k 4 root 80 x minus q1 q2 8 root 80 y. So, this is the F23. Now, the total force is the sum of these two forces. So, how do we get the sum of these two forces? So, let us just do this, calculating the sum of these two forces a little more carefully. So, what did we find is that F21 is equal to, we got that minus 0.6 q1 q2 divided by 100 k x cap minus 0.8 minus 0.8 q1 q2 by 100 k y cap. Similarly, F23 is q1 q2 by 80 k into square root of 4 root 80 along x axis minus q1 q2 by 80 k 8 by root 80 along minus y axis. So, this is this force, and F21 plus F23. So, when you say F21 plus F23, this is the x component and this is the x component. So, if you sum this x component, that will be the x component of the total force. So, what is the x component of the total force? There is q1 q2, there is q1 q2 by k. So, let us take it common, q1 q2 by k, and there is 1 by 100 here, 180 here. So, 1 by 100 plus, there is a root of 4 by 80 here, there is a 1 by 80 here, this much along the x axis. This is the total force along the x axis. If you substitute all this number and calculate, you will get some number. So, I urge you to calculate this number by putting q1 equal to 1, q2 equal to 2 and the value of k, which you can estimate. So, if you take the epsilon 0, epsilon r of water you can take, because proteins are in water. So, I urge you to calculate this number. What is the force along the x axis as an exercise, but you can calculate this by substituting all this number. Now, similarly, there is some force along the y axis, and that is this much. So, this is the force along the y, this plus this. If you sum these two, you will get the force along the y axis. So, how much is the force along the y axis? So, let us write the force along the x axis is q1 q2 by k into 1 by 100 plus square root of 4 by 80 into 1 by 80. This is along x axis, minus along y axis. So, we had q1 q2 by k here also. So, and there is a 0.8 by 100. So, okay, there is a 0.8 here actually, there is a 0.6 here actually, 0.6, because there is a q1 q2 and then there is a 0.6 here. So, q1 q2 by k into 0.8 by 100, this is a minus sign, and this is also with a minus sign. So, I can take the minus sign also common out. So, and there is plus root of 8 by 80 into 1 over 80 along y cap. So, this is the force on the second charge, this much along the plus x axis and this much along the minus y axis. So, there is, as you can see, F2 is some number along the plus x plus minus some number along the y. So, this is some positive number, this is some positive number here. So, let me call this alpha, let me call this beta. So, some number alpha along x axis, some number beta along the y axis with a minus y axis. So, where alpha is given by this particular number and beta is given by this. Where alpha, so this is our alpha, this is alpha. So, this is alpha for you and this is beta. So, we know alpha and we know beta, and we know that alpha x cap minus beta y cap. So, what does this mean? This is a this itself gives you some idea. It means that some amount of force, there is some force along the plus x axis and there is some force along the minus y axis. The total force is along the x axis and something along the minus y axis. So, have a look at here. What does it mean? There is some force along the plus x axis, some force along the minus y axis. So, let us look at this little more carefully. So, when you look at this carefully, so you have three charges and you had this plus q1. So, this is q2, q3, this is q1 and this is q2, and we ask the question, what is the force on this charge due to this charges? This is plus and what is the force? And we found that the force F2 we calculated this F2 and we got F2 is some alpha x cap minus beta y cap, where alpha and beta are some numbers. We got a number for alpha, we got a number for beta. What does this mean? This means that there will be some force along plus x direction, there will be some force along this direction and there will be some force along the minus y direction. So, essentially it will slightly move this direction and this direction. So, we got already the precise answer. We know now that it will not move this way, it will not move this way, it will not move this way, it will only move a little bit here and little bit here. So, that is the force. Some force, a bit of force along x axis, a bit of force along y axis. So, we got the idea about the force, and that precisely tells you in which direction this charge will move. So, that is the question where we started. So, if we go back and see where the question we started. So, we started with this question: in which direction the negative charge will move. So, now we know the answer. It will move a little along the y x axis and a bit towards downwards y axis. So, it will move slightly towards this plus charge, essentially this plus q here, this charge. That is what essentially it will move a bit. How much it will move, that we will calculate later, but the aim was of this exercise was to calculate the force on this due to other charges. What is the resultant force? What is the total force? Whether it is the total force is in this direction or in this direction or in this direction. So, we saw that it is none of this, it is along this direction, the total force is along this direction. So, that is what it means. So, essentially we have now discussed what is, we have now understood how to calculate the force. So, let us summarize whatever we learned today. While we calculating, we learn many things. So, let us have a quick summary of what we learned. So, let us summarize what we learned today in the last many minutes. We basically learned how to calculate the force, and while learning that, we learned to calculate the magnitude of a vector, we learned to calculate the unit vector, we learned that unit vector means direction. So, 3 ideas from vector algebra we learned, and we learned how to calculate the force. So, essentially the summary is this: we learned finding out the resultant force, we learned what is a unit vector, we learned the magnitude of a vector, we learned the unit vector represents the direction of a vector. So, knowing all this, we are equipped now to calculate if you have, for example, many charges or many forces acting. We know what is the resultant force. We know how to calculate if you know, if you have a particular vector in a particular direction, what is the unit vector, how to calculate that we know. So, we will make use of all this when we go along. The many phenomena, as we said, like diffusion, etc. To understand all this in a proper manner, we have to get some sense of direction, and we have to know precisely how to calculate this direction of a vector. So, this is the first step, and what one should do is one should sit for a long time and do all this calculation carefully, spend long time with pen and paper doing all these calculations carefully many times, so that it will be very clear in your mind. So, learning this much, we will stop today's lecture here, and we will continue a few more ideas. We will learn a few more ideas of vectors in the coming class. So, and we will go ahead using this idea of vector. We will learn more interesting biological concepts. So, with this we end today's class. Thank you.